Wait till the time.
That's how to apply your psychology knowledge in calculus.
See, I never took psychology.
You haven't taken psychology?
I don't know. Because I have too many humanities as it is.
Which humanities did you take?
I took like art and music and sociology and...
Are you tired of humanities yet?
Yeah.
I've
I
only
want
taken...
math and science.
I took the sociology, psychology, and humanities.
What was... Oh, for your
Study
trip?
abroad. I get to take the continuing subversion.
For Costa Rica.
Yeah, I have to pay for it.
Oh, nice.
But the good thing about it is I don't have to do any work. All the homework assignments are just for people taking it for credits.
Are you taking it for credit?
No.
So you
I already
just
got
do
the credit.
homework?
I got the credits from last year. I don't want to do it again. Okay. So I finished 3 notebooks so far in this class.
Savvy!
What?
I haven't even finished one.
Seriously?
Yeah.
But you have the graphing notebook.
And you do homework in your notebooks.
Yeah.
See, my homework
Or I
says
did
it.
do homework in my notebooks.
Don't say that too loud.
Now I do them on loose leaf paper. So my hopes are that I can finish this right at the end of the semester. Nice hat.
Nice
Rizzo.
hat.
Thanks, man. That's warm.
Looks cute. You're sticking out. Where'd you get it?
I don't know. I've had it for a long time.
Looks comfy.
It is extremely comfy and warm.
I really like hats like this.
Yeah. There's
Hey
some.
Rizzo, do
Yeah.
you want to bargain for extra credit for
Yeah,
us?
tell him 10 points first and then save for 5 on your
Why
final.
am I gonna do that?
Because you're
He
friends
loves
with
you.
him.
Yeah.
Did you talk to Mason over the weekend?
Yeah.
He was sick.
He
He
was
was sick.
He was sick. I mean, I forgave him.
He
for
was
it.
Did he
sick
not
on
hear-
Thursday when he talked to me.
You knocking on the door?
You couldn't come
He
to the
told
door
me
and say
he
sorry.
heard.
I'm sick.
He said, I thought I heard knocking, but I thought I was just sick and delirious.
Jeez, Mason. That was his excuse. For
Yeah.
lying.
He probably just wanted to sleep realistically.
Or
You should have like
went to
gone
the
around and
parade.
knocked on the windows until you got to his room.
Did he go to the parade?
So moral of the story, I didn't knock loud enough.
Moral of the story, we just had to scream.
I don't think anybody heard this.
And then his parents answer the door.
Yeah.
No one was there except his car.
I mean, he was. According to him. I brought a pot of rose.
Next time I'll knock on windows.
It's a lot.
Where's it at? In your car? Toothbrush.
We're muted.
Way to go, Rizzo. He's gonna take 5 points off of your final.
Yeah, why? Because I acknowledge his reason for absence?
Yeah.
I wash my dishes for him.
I read that.
That's so funny.
They're not even there.
Yeah. You know what? I don't get.
It's your goals.
No, I actually got working with him.
Riemann sums?
I got to screwing around with them, and I could now do like the limit as n approaches infinity thingy. But wouldn't life be a lot more convenient if we could just use those formulas?
Yeah. But you had to ask.
Or it's just k, and k is b minus a, and k is 1/3 b cubed minus a cubed. I know it in my head. I know it in my heart.
Whoa, that's not what I wanted to do.
Hey, you should just zoom in on me.
Stop. I'm
Rizzo,
trying to
Oh,
miss.
Stop.
sorry.
Now you lagged it.
I'm sorry. Forgive me. Yo, why is it warm? Maybe it's because I'm wearing this high-arm sweater. It's a turtleneck. It's a button-up turtleneck. It's the
So,
weirdest thing I've ever heard.
what things can't we use unless we prove them on the test?
The cube thingy.
Why is this?
It's basically like derivative rules when we were just using the fundamental derivative.
But those are so much easier.
They
So
are.
we can't use the definite integral formulas?
No.
Nope.
We can use everything else though.
If you prove it though,
But
you can.
prove it.
Same if.
You don't have enough time to prove that.
Yeah, you can.
Exactly.
Same if you use brute memory, you can.
Who memorizes things
Congratulations, dude.
Hey,
Success.
Oh, thank-
And Rizzo has something to talk to you about.
Rizzo, ask.
Come on, Rizzo.
Why
The
Because
pressure's on you.
am I like the Republican representative now? Or-
let's go.
Oh yeah. Should
Press
I
the button.
ask?
Press the
Press
button.
the button.
Should I ask Miss Klinger?
It can't hurt.
Please, we need it.
I am
Neutral.
Where'd he go?
Switzerland.
I'm
Okay.
What, a band of mercenaries
Come
invade
on,
their own
Rizzo.
country
Go
in the 9th
Rizzo.
century?
We're Austria, and he's Germany.
Yeah, I don't think that's how it works.
Encouraging
Rizzo,
you.
push the button. Push the button.
Push the button.
Give me a second.
You might as well do it now when there's not as many people. in
Okay,
But
Mr.
I don't
Gaddis.
even know if he's there.
Walked out.
Oh, that's okay. I'm okay with that. You know, I've never seen your face, Mrs. Camera Lady.
Joe?
Joe?
You haven't seen her?
No.
No, because she's behind the camera all the time. Take a selfie. Oh, wow. Dude, why is this room straight octagonal?
White.
Straight hexagonal, my man. It's like we're trying to imitate the amphitheater. It's the most acoustic stadium ever to exist. What did I do this weekend? What did I do?
Some math competition?
Oh yeah, that's right. And then I went to the Festival of Lights.
How was that?
It was okay. I just ate Chick-fil-A in a car with Manny. This one girl.
Was she okay?
I mean, she seemed to be. She's usually pretty
There he
quiet.
is.
Oh yeah,
Press
Mr.
the button.
Gaddis.
Hey, good morning.
Did he say more or good morning?
Good morning.
Good morning. Good morning, Mr.
Good morning,
Gaddis.
guys. Good morning.
So,
Welcome to the call.
my
Well,
peer's question
Question.
regarding the competition. Do you think because of your pride in us, you could lend some extra?
He said, hang on.
Something.
Friday. Friday?
Do you think
I'm
you,
sorry, I couldn't hear you. The fan was on.
because of how proud you are in us, do you think you could lend us some extra credit, perhaps?
That was your extra credit.
Okay.
I'm proud of you. That's extra.
Oh my God.
Wow.
Well, I tried.
You could just put it on there, not
What kind of test did they have there? Was it calculus test? Was it?
Yeah.
Yeah.
Show it to you. It's bad.
They had a lone calculus test and then a
Shrink
group
test.
pre-calculus test.
Ah. We got this test.
Durham Tech pretty much ran away with it.
all
Yeah.
of it. They got
Except
everything
for
except
the
one.
trophies.
Well, they couldn't get multiple trophies because they did order.
Durham
test
Tech
schools,
won all of it.
except
Yeah.
for one thing.
Who did?
They just no. Durham Tech.
Durham.
Oh, Tech ball. Isn't that where Chris is from?
Yeah.
Well, yeah, Chris. I remember Chris. He asked about you, Mr. Gaddis.
Yes, he did. And then he said the dishwasher.
Well,
was-
I was crawling around in the kitchen cabinets all day Saturday trying to get the dishwasher out and get a new one in.
But that could have been
Managed
so.
to get it working, no leaks the first try. I couldn't believe it.
These paper plates were
I'm
great.
definitely not a phone. Well, I'm here by else.
Now let's see if we can even eat anything at home.
What sections is this on? 4.12?
2 and 3.
and 3?
Yeah.
So,
Yes.
how did y'all do differently on the calculus versus the T?
Oh yeah,
Was it
for
like-
sure.
Oh yeah, we did pretty good.
The
in
I used logic though. It was pretty awesome.
Yeah, I did too.
I think that deflated my ego a lot.
What
I
ego?
went in there feeling all smart, like we're almost done with Calc 1, I got
We
this.
can do this, and
then I got
It
5
was
questions.
just like
No, just kidding.
2 lines. One of
spoke
them.
too soon.
Like what happened is I got 5 C's in a row and I was like, that can't be right. So I started mixing.
Good. That's what I'm saying.
Did
So,
you do
so
for
you got
sure?
that place you're not even had Calc 2. That's impressive.
And then I got to the second one and I'm like,
Just kidding. The first question was about F increasing, and they knew that one.
I don't believe in F.
What?
More of a G man.
The function increasing on what interval?
did everyone get
G
that?
of X.
All right, because well, truly, it's truly even more impressive. So it's part of it on Calc 2, and we, not had Calc 2. So that's
Differential equation. It's the worst.
just think how well you'd do in Calc 2 had you signed up for it.
Oh, yeah, totally.
Oh no.
I think I'll start there.
Hey, Raisin.
Yes?
I'm taking Calc 2 next semester.
No.
Why? What do I do with it?
I can put it in my math.
You're
Okay,
what?
so now it's
I would, but I can't.
you're pre-enrolled. Everybody's like,
Right.
I'm trying not to retake anything.
if they run it, and if everyone can move it, then I'll.
Calc 2.
Well, wait, I can't. I got a class.
But you
I
have
have to- we can do a different time, but I have to have an 8 time.
I'm good. I'm good actually.
I think I got 3.
Bye.
the person that's doing good
That's
does take more.
F1 had. We always had
Oh
high school.
boy.
So we always had 8, 4, 2.
Yeah, that's why he's artist.
Look at that, then the sciences go,
Calculus artist.
don't have confidence, so kind of stuck for which,
Oh yeah, Mr. Gaddis.
that's,
We met a guy named Dale Boger.
Bill, oh,
Yeah.
kind of lady, Sammy.
Was that deck? He doesn't get it.
He said he was like a fusion between you and Sammy.
Interesting. Where was he from? She from?
Forsyth Tech.
Forsyth Tech. Was it a student or an instructor?
No, he was an old guy.
Well, wait a minute. That could have been me. Yeah.
He had a beard though.
Oh, well, I have a.
It's like, cousins, we need to talk later.
I have a rule. Joe has a beard.
They knew an old guy, they didn't know if he was a student, but he had a beard. So I'm like, well,
What's that?
Joe,
Skip Britlet and go.
okay.
That's tomorrow.
Yeah.
No, we don't.
Yeah, we have.
It's tomorrow?
Yeah.
and calculus
It's
test.
okay though. It's just Britlet. It's nothing.
It's just Brit.
Yeah, it's just Britlet.
Just stop it.
It's just Britlet. Britlet's everything.
Well, have we really read them though?
Yeah, that's the point.
I mean, even if
Because
you
I haven't.
I didn't even
Hey,
the last
I
two
managed to get through that
things.
class with a 100 average, and I didn't read anything but Beowulf.
I mean, Beowulf is awesome, dude.
Sure.
It took me forever. I listened to the audiobook, and I kept having to rewind it because I missed like.
You know what's better than audiobooks? Looking at letters and reading words off of it.
Really?
Or reading words while listening to it.
I'd rather listen to Bill.
I can't pay attention though.
See?
After like
Huh.
8:30, I'm out of this classes. I just-
And I
Is
can
that a squirrel or a
into
fox?
this.
I forget.
A penguin.
No, that.
That's a fox.
Hey, what is this?
A phone. Nice. Is this a case?
No.
There's no case.
Questions on that?
Oh yeah, questions.
Start from the beginning and go through.
Can we review everything?
Good, it's actually, which section? 4.3. 4.3, number 33, I heard.
33?
Why not?
Yeah, I was gonna ask on that, because it said it was not enough information to answer it.
Wait, did he say 43 or 30?
I think he said 33.
Yeah, 33.
33. They give us a bunch of pieces of information.
Why?
Because I take Spanish.
Why don't?
Good for you. Actually, no, we're gonna have to pay for it later. Somewhere.
Why won't?
Yeah, I don't know.
Take the bare minimum and pass through that.
I feel like there's another person in our class. I can't put my finger on it.
Person?
Well, yeah, them. Oh, he forgot the DX. Excuse me, XD.
Okay, it's asking us to find the definite interval from -2 to 3 of f of x times g of x. Yep, not enough information, I agree.
What?
Okay, yeah, I mean, that's correct, but can you, like, verbally explain in a thorough and succinct manner why that is?
Distinct manner.
Yes, it starts with order of operations.
Mm-hmm.
That was thorough and succinct right there.
So
Order
could
of
I just
operations.
say, I don't know a product rule for integrals, so I can't really.
Yeah, there isn't a product rule per se for integrals unless it fits a special pattern that we haven't discussed yet.
Yeah. So
There isn't a generic one for product, and also, why is there not a generic one for product with two functions? I mean, if there was, it would look as you might expect. You know, I guess what most people are thinking is, if there was, put a question mark, then thinking that it would look like this. But why can that not be true? Potentially, there could be a sign issue, SIGN issue in this, I agree. That also, I think, is related to the fact that it's an order of operations issue. To help better understand it, let's review what's the definition of, say, that thing right there.
Limit as n approaches infinity of the sum from k equals 1 to n of f of x times g of x delta x.
What do we have?
Is there a product rule for sums?
Now, why is it's not true? Yeah, I didn't have enough information at the beginning. Unless I knew something more specific about the two functions I was dealing with, I couldn't, in general, do this, which is what most people would want to try to do. Here's why. Just apply for it.
Okay, so how's that explained? Okay, Mr. Gaddis.
Goes back to something very fundamental in algebra, like you know that a plus b squared is not equal to a squared plus b squared.
Okay.
Recognize this. This is only lines. Of what's happening. Here you're taking the sum of a bunch of products, and the question is that equal to the product of a bunch of sums? I guess really, if I wrote it the other way around, I'd put it this way. Now it matches the same order as I had before up here. So the sum of products is not equal to the product of sums. Sum of products is not equal to the product of sums. It's a curve operations issue.
Okay.
Going back to the definition. Right? Did that explain it now?
So it doesn't work because the left side of the equation does not equal the right side of that equation.
Right? Why does it not equal?
Because of order of operations.
Yes. You can even write in words that the sum of products is not equal to the product of the sum. Except for very special cases.
Mm-hmm.
One or two. Okay.
Can you do 35? That's another not enough info.
Not enough info. I'm going to say it's the same reason. In fact, that even more precisely, in fact, because I've got g of x squared, that fits exactly the look of this right here. There are some ways to handle products in integrals, but we don't learn those until Calc 2. But it is not a direct product rule like this. There's some special techniques that you can manipulate the products to make them into something we can integrate, find an integral value. That's Calc 2.
Okay.
Could have been helpful on your test this week, I'm sure.
Yeah, you're probably right. Oh well.
That's all right. Still been well considering I hadn't had Calc 2. Okay, so 35 is the same. Any other questions? Rachel?
Okay, so on number 23, this is the part where it wants us to find the area by looking at the geometry of the function. And so what I was wondering is signed area only for like the top and bottom half of the graph? Does it not work for the left and right?
That is correct. The sign of the area depends on whether you're above or below the x-axis, but also if you're going, as we learned one property, you're going in from right to left. definite interval has you going from right to left, that also changes your sign. That makes sense?
Yeah, but
Well,
so
you
it
know,
doesn't.
this one, from -3 to 8, -4 to 8. Is that what it was? -4 to 8?
Yeah, you know, it's -3.
-3 of 24, is that right?
Yes.
I mean, this is 24. There's the function y equals 24.
Mm-hmm.
We're going from -3 to 8. As long as we're going this direction from left to right, so it says -3 is my start, 8 is my end, so then I'm going this direction, which means delta x is positive in that direction. And my heights, all of my heights, is positive in that direction, in the way that it's drawn. So my area should be positive there. Does that make sense? Versus if I reversed it by the theorem that we learned last week, this would be the opposite of if I went from 8 to -3. On the right-hand side of my equation here, if I went from right to left, I went this direction, for this one, so I'm starting at 8, ending at -3, so I'm going that direction, so that makes delta x be less than 0. But I still have heights greater than 0, so I'm going to end up with a negative area.
Yeah. So if you went below the x-axis,
Yes?
if you went below the x-axis and you were going right to left, would it be positive then?
Yes. Yes. If you had this situation, and you were doing the depth integral from b to a of f of x, this is f of x down here. And on this situation, since I'm starting at, there's my start, there's my end, I'm going this direction, so that meant delta x is now less than 0, and my heights is less than 0. So this number is going to be greater than 0, which is curious, but it's true. Now on this one, again, if I went left to right, then I would have a negative area because it's below the axis. But if I'm going right to left, I've got negative of a negative area. Other questions? 25. Use geometry. Find the exact values using the definite. It's 1 minus x squared square root of -1 to 1. So I guess the first thing is to understand what is the graph of y equals the square root of 1 minus x squared. What does that look like? I recognize that shape. Well, if you don't immediately recognize it, you could square both sides and you get y squared equals 1 minus x squared. If you add the x squared over, you get x squared plus y squared equals 1, which is a unit circle centered at the origin.
It's like squaring both sides.
Wouldn't it have to be only the top part since it's technically a function?
Yes, it is. You're absolutely right. I was going to get to that one moment. Thank you for letting us all know. So this is the unit circle, but Sammy or Chloe pointed that out to us. I couldn't see it. So,
Sammy.
Amy, thank you. Yes. So the black circle is this equation here. So this is that. But we were looking at this. Here, y is positive square root of that. So that means my y value is always positive. So then it had to be, since y is always positive, it had to be top half of this circle, so a semicircle. So this is y equals the square root of 1 minus x squared. So, how do we calculate now the area under that function curve? Since it is a function curve, so we're not worried about this bottom half now. This was just there as part of my thinking.
Can we the area of this
area right?
Yeah, you
Go
got
ahead.
it.
by 2?
I like it.
That's what I did.
We find the area of the circle and then divide by 2.
Yes. This is just 1/2 area of a circle. 1/2 of what's the area of the circle?
Pi r squared.
Pi r squared. So r this time is 1. Pi over 2. Okay, other questions?
You want to see what I did?
If it had been the whole circle, that would have pi r squared as the area of it. But I'm only using the upper half or the lower half. If it had been the lower half, what would have been the number?
I feel like that'd be good.
Negative pi over 2. That's fine. If it's below the axis, with the negative. Okay, other questions?
Where'd he go?
Five. No,
He's looking down. You have to use your voice, man.
oh, maybe. I thought we started that. I'll do it again. I think I'll do it again.
You're right. What 5 chicken farms with that?
Yeah, I know.
41, not 45. Okay, we'll do 45 now.
Yeah, it is.
Okay, x plus 1 quantity squared. Negative 2, no, 2 to 3.
Can't believe I have to do this. I have to find out what it is.
Directions want us to do what? Want to find an R of n. We want to find, first of all, R of n. Then we want to find R of 100. We want to find R of 1,000. Then we want to find limit n goes to or R means right sum. So right sum is going to be
The sum.
I want to do a right sum with the right sum.
Bless you.
H equals 1 n
Of f of x sub k times delta x.
Yeah, that gives me a right sum within rectangles. Piece of information I might need is I need to rewrite x sub k as a function of k.
Mm-hmm.
So I use A plus K times delta X. So now I've got it down to a function that I know of a function of K and delta X. I just need to know the pieces in the puzzle there. Looking over here, I have A is 2, delta X, excuse me, is 3 minus 2 over N. Oh, I feel like we're done. It's not complicated.
Yeah, we got close to it. It was a different question, though.
And go through it one more time, or I guess this review. So my function is x plus 1 squared, so this is going to be, there's my x value, a is 2 plus k times 1 over n plus 1 squared times 1 over n.
Where's it?
There's my function, x plus 1 squared. At this stage, you got, different things you can do. It's probably squared out, I guess. This is a 2 plus 1 is a 3 plus 1 over n times k squared times 1 over n. I'd probably go ahead and distribute that out. Let's see, so 3 times 3 is 9. So I get 9 over n plus 6 over n,
6k.
6 over n squared times k plus 1 over n cubed times k squared. So if I distribute everything out, I think that's what you get.
Mm-hmm.
Now you can rewrite this as using rules of summation. 9 over n is constant relative to k, so I got 9 over n summation k equals 1 to n of 1 plus 6 over n squared is constant relative to k, so 6 over n squared summation k equals 1 to n of k plus 1 over n cubed times summation k equals 1 to n of k squared. I guess I have to go to the next board now. So that gives me times n, 6 over n squared times n plus 1 over 2 plus 1 over n cubed times n plus 1 times 2n plus 1 over 6. That's a function of n. Now we've got it down. We're asked to find a right sum as a function of n. We've got it down to a function of n, so basically we're there. The only thing I would say is clean it up a little bit. However, different ways of doing that. So let's see, that's 9 plus. N squared, well, I can cancel that in one of those. So that's going to be 3 times n plus 1 over n plus, I'll cancel an n with one of these, so that's going to be 2n squared plus 3n plus 1 over 6n squared. That's a function of n right there. You can continue simplifying further, get it into a single fraction. I'm going to stop there this time, since I feel like it's. So now we can do, there's R of n, we completed that. Now we can do R of 100. That's 9 plus.
You're gonna do, man. You should have simplified. Oh, you have to calculate.
303 over 100 plus whatever that is. 100 squared, whatever. 1,000 plus 300, 1,301 over 16,000. Whatever that is, you can plug it in and get some number. Then you can do R of 1,000.
So how's that? You good? You want to Texas for Christmas? Texas. Or not Christmas, Thanksgiving. I'll be better. A real holiday. Yeah, what I said. Yeah. Why Texas? Undertale is the cause of our speed. Patrick.
Okay, so do we get some number approximations here?
Yes.
Yeah.
If I get R of 100 calculated. How did you get?
Gone.
What about R of 1,000?
12.336.
Okay. How we can find the exact value of F interval by doing the limit as n goes to infinity of this sum that we've created. Take this R of n sum and let n go to infinity. So I guess if you do some L'Hopital on it, you already have a 9 there, but if this one's going to be infinity over infinity, if I do a L'Hopital, I'm going to get a 3, it looks like. Then over here, this is infinity over infinity. If I do a L'Hopital twice, I'm going to get a 2 over 6. So that's equal to 12 1/3.
Yep. Got him. Got him. I don't use mixed numbers. I'm a purist.
Questions on doing this now?
Oh yeah, I have a question.
Which question?
When you want us to evaluate definite integrals, as in applying the limit as n approaches infinity for infinite rectangles, is that going to have to be, as a preliminary step, are we going to have to do a kind of Riemann sum, like a right sum or a left sum?
Yes, to find the exact value of definite integral, for now, we have to do a Riemann sum, which is the definition.
So I have to choose like a left or a right or a midpoint?
Correct.
Yeah.
And the right sum is usually easier because it's simply a plus k times delta x. But let's review that. How would it be different for a left sum on here if I wanted to do a left sum? Which you're allowed, but what would it look like?
Would it just be A?
So last sum, you use the point before. So instead of x of k, use x of k minus 1. So this step right here is going to look like not that big of a deal. It says a k minus 1 multiplier instead of a k. Midpoint, how do you do it? You know, with it, you would just, now you're just going to plug in this x value into your function. It's just a modified x value. And on your approximations, your answers will be different than those, but on your exact value, it'll still come out to be the same. And when you let the number of rectangles go to infinity, then the width of them all shrink down to 0, so it doesn't matter if you're left or right. Once that width shrinks down to 0, it'll fit perfectly.
Mr. Gaddis.
That's crazy.
On your simplification of the right sum, on the right side of that board that you're standing in front of, if you were doing that for a left sum, would everywhere that there's k, would that be a k minus 1?
Yeah.
Wow. Okay.
Right, sums it is.
Yeah, right sum it is.
Yeah, exactly. This, 2 and a k minus 1 right there. And then you're going to have to, somehow combine like terms. So, yeah. It's not, it's just an extra term in there that you'll have to combine with other terms. That's all. But yeah, it's easier with the right sum than it is the left sum or midpoint sum, especially if you're trying to set up this same kind of plan to get to an exact value. Now, if you're just approximating, and that's all you're going to do, with maybe 5, n equals 5 or n equals 8 or something, it's not a big a deal there. But when you're trying to set up this whole process all the way to n goes infinity, usually right sum is easy. Other questions?
Can you write what the midpoint sum thingy would look like? The thingy that you wrote in.
Since we wrote that one, let's go and write the midpoint sum. What would it look like? I guess I'll take this one step further and at least get to that step. So this would look like, as you pointed out, it's going to look identical to this, but instead of a k, you now have a k minus 1 times 1 over n plus 1 squared and times 1 over n. And then if you wanted to do a midpoint sum, what does midpoint somewhere. So it's f of the midpoint between two x values. So it's x sub k minus 1 plus x sub k over 2. That's kind of, again, the first step. F of some x value, but the x value is the average of two of them. So k minus the term, the x value at k minus 1 and the x value at k, you average those two together, and then take your function value up.
Oh my gosh.
Let's take it a couple steps further. How do I write this? This is an x value. It's halfway between each of the x values. I went over this one time before, but I mean, excuse me, draw a picture again. What is it? What does it look like in terms of generating these x values as a function of k, like we did here and here? We generated the x values as a function of k, both of these places. I need to do the same thing here. So what does it look like? This is x0, your starting point. This is x1. That's x2, and so on. We're now hitting, instead of the left or right, we're hitting these midpoints. How do we generate those midpoints? Starting at A, same idea. We started at A, then we added something onto it as a function of K. What did we add on? Say again? Almost. Is it all of the half delta x?
All of the
Odd
half delta x.
So, in other words, this distance here is 1/2 of delta x, but this distance here is 3/2 of delta x, and so on. So, you're doing all the odd half delta x's added on to A. So this is going to be A plus, and how do I write odd half of delta x?
Is it going to be k over 2 delta x? Something like that?
It would be delta x over 2.
Or someone sort of have to say it.
Do something with k, but I don't know which is
Is it k over delta x? Is it k
No.
plus 1 over delta x?
I've got to actually multiply something times delta x. Not divided by delta x. But I don't want just 1/2 times delta x, because 1/2 was good. That would hit every single one of them. If I put k times k, I could be like, think about this. If I put k times 1/2 times delta x. Well, then that means when k is 1, you go to here. But when k is 2, you do 2 halves, which puts you there. I don't want to be there. So when k is 1, this one has to be k equals 1. That one has to be k equals 2. So when k is 1, I get a 1/2. When k is 2, I get a 3/2. When k is 3, I get a 5/2. Think about that. K is 1. I want to map to a 1. When k is 2, I want to map to a 3. When k is 3, I want to map to a 5. So how do I generate 1, 3, 5 with 1, 2, 3?
What is it going to be?
K minus 1.
Yeah.
This isn't going to be right. 2k minus 1 over 2.
Ew. How are you going to put that into the dinghy? Oh my gosh. It's going to be nasty.
Like kind of
Just kind of simple.
right, so you ended up with K delta X because you had F for X sub K,
Yeah.
the left sum you ended up with K minus 1. The bottom one for the midpoint, is it always going to be just the K's? Okay.
Joe's making an excellent observation here, folks. I was trying to get you to think about making an odd number as 2K minus 1. Joe observed, look, we did X sub K here and we used the K there. We did X sub K minus 1 here and we did K minus 1 there. Here we did K minus 1 plus K makes 2K minus 1 over 2.
Oh,
It was just K minus one.
Nice.
Observation.
fair.
There's your midpoint sum. What about trapezoidal sum? That's one we haven't talked about today. Remember how to do trapezoidal sum?
Trapezoid.
It looks a lot like midpoint, except instead of averaging the x's, you're averaging
The
Y.
function use.
And so I can't easily make some kind of formula like this. So it's its own little separate beast. So T of n, trapezoidal, is the sum of f of x sub k minus 1 plus f of x sub k divided by 2. That's the basic plan there. But now we're doing the function of x plus the function of x. We're not doing, over there in midpoint, we did the function of x plus x, which is a different game. Here we're doing an average of the y values rather than the average of the x values. So the only thing I could do with this is I could write it out, adding up all of the terms and kind of simplifying it. That's just the basic plan. But if you wanted, you could write this as something like this we talked about. First, use the first x value once, and then because of the idea of using a left and right side of each rectangle, both sides, you're using both left and right sides all the way down, then the middle, all the middle values get used twice. And I ran out of room, but all of this has to be multiplied by delta x over 2. And that delta x over 2 comes from the fact that you are dividing this sum by 2, so there's the 2, and you multiply by delta x, so there's your delta x over 2. But all of the intervening terms, other than the first and the last one, you're using them twice because you're using them in each side-by-side competition. A simple way to write that down into a nice little summation.
So it's not possible to have basically a plus k delta x plus the other.
Correct. Yeah, the trapezoidal sum, we can't write. Like all three of these, we were able to convert to an a plus k times delta x or whatever, a plus k minus 1. We can't do this game in trapezoidal because we're averaging the y values, not the x. We're not, so we can't do this. All we can do is we need, what else? Set. 4.3?
Yes. Does he use?
I again, I didn't go over the formulas and, you know, I think we just made up the way we did here. So, because you asked if you could use those special formulas, I said yes if you put them on the test. So on the test, what do you gotta have on the test? Main focus is on definite interval. So, how do you read that notation? Say again?
Definite interval from A to B of f of x.
Of the dx.
Do I just say dx?
Dx, or it could be like in derivatives. Remember when we said with respect to x, derivative with respect to x? This is the integral from A to B of f of x with respect to x.
With respect
Or
to
you can say dx. That's a good question. There is something that we'll learn about soon called indefinite interval. So this is a definite interval. Generally speaking, just say integral. Most people think of definite interval versus indefinite. But some people think the other way.
Oh,
I don't know why. I don't know what this book says. I think they made a blurb somewhere about when they say integral, which one they mean. It's the definite interval from A to B of f of x with respect to x. What's the definition of it?
Oh, the definition of it? Well, the limit as n approaches infinity of the sum from k equals 1 to n of f of x sub k star delta x.
Put stars in random places.
Also, I don't know how he does that star.
What's that called that we just wrote right there?
It's a Riemann sum
That's
going
a
to
Riemann
infinity.
sum with a limit. Limit of a Riemann sum. Limit n goes to infinity of a Riemann sum. Good. What is it? When you make this calculation, what are you calculating? And then more precisely, the sine variable. The sine variable between the function and the x-axis. Okay, so how did we calculate this when we actually had to sit down and calculate? That's the definition of it in the brief overview explanation. We use right sum, left sum, midpoint sum, and trapezoidal sum, which we just went over.
Trapezoid.
Got to know all those.
Trapezoid.
I have a question.
Yes.
Are we gonna have any proofs on our test that we need to know?
I would know no formal proofs. Maybe some explanations though. Like informal proof.
No explanations.
I'm gonna have to use words instead of numbers these days.
We'll say he owes us points because he fixes the dishwasher instead of coming to our.
Oh, you weren't even
Yes.
there for that.
Good question.
Now we gotta
Oh,
make
yeah,
that
we-
hard.
Actually, no, we're still in class. We can't talk about that.
Now,
We were just thinking of some dumb mistake we made at the math competition.
you're owning it? Good. What was the mistake?
Put 22 instead of.
It was 20. Basically, one square kept us from $50
Each.
each of us,
And a trophy.
and the trophy.
Yeah.
Actually, we wouldn't even gotten a trophy. We would have gotten medals though.
It's pretty disappointing.
Amen.
Yeah.
We were so close.
Oh my gosh, it was so dumb. Do you want to hear the question?
Do you have
Pardon me?
Do you want to hear the question?
Yes.
The worst part is that
It was x.
Plus 1 over x equals 20.
No, it was x plus 1 over x is equal to the root of 22. If that's the case, find x squared plus 1 over x squared.
Okay. So what did you do?
We messed up.
guys
Square
and
roots.
I got them.
Yeah, what?
We got the answer in the
For
middle
both
of
sides?
So upset with myself.
Yeah, we got in the middle of the work, but then we tried to plug in 20 and then everything just fell apart. 20 was where we should have started.
Well, you're under a time limit on that also, aren't you?
Yeah, well, we were trying to be fast, but we weren't
Right,
even
that's
fast. We
what
were
you-
just slow and wrong.
That's the worst.
Sometimes it does that. It just goes sideways on you.
Yeah.
Okay. Well, what else? Any other questions about the test? See, the main focus will be definite intervals.
Yeah.
Doing those by approximating with right sums, left sums. Most of that will be small numbers like R of 4 or trapezoid of 6. So most of the work will be dealing with functions that you cannot easily determine an exact value. Again, which ones can we easily determine at this stage in our academic career? Which types can we determine exact interval values, definite interval values? If they're x cubed or lower degree polynomial, then we can use those special formulas to calculate, like here, we use these special formulas to calculate an exact value using n goes to infinity. But without those special formulas, we don't have the skill yet. So we'll only have to do that a little bit. Most of it will be with a small number of n on some function that's not equivalent by exact values, at least with our current knowledge. Okay? So you're
Oh, yeah, Mr.
doing
Gaddis.
yeah, most part.
In the instance that we'll have to do something really long and drawn out like that, should I anticipate doing right sum?
I would anticipate doing a right sum. You can choose to do a different one, but if it were me, I would choose the right sum just because it's a little bit shorter, a little bit easier.
Yeah, you're right.
Also have some where you have to use geometry, like we've done here. Like I said, maybe explain something type of problem. Too. It won't be one that you can get an exact value. One or two that you can do this way and get an exact value. You have to do that. You have to use those special formulas. You have to get an exact value. But a lot of it will be simply approximate using 6 rectangles. So that means have your calculator be speedy at calculating heights at function values at 4 or 6 different x values.
All right.
10 minutes. We got 10 minutes.
What ifs and disappointments.
$50, Carson. That would have been $200 in total. We could have gotten him a new dishwasher.
I'm sorry, I got a hand. Yeah. Yes, Josh.
I have a quick question on chapter 4.2, number 39.
4.2, number 39. Let's talk about that.
To talk? If we have time?
I think we should.
Write out the sigma notation for the Riemann sum described in such a way that the only letter which appears in the general term of the sum is K. Don't calculate the divided sum, just write it down. Okay, so number 39. Oh. Number 39 we could not actually calculate because it's not a degree 3 polynomial, so not an exact value. This says just use n equals 4. So I can actually calculate that. Write it out in sigma notation. Okay. You got f of x equals the square root of x plus 1. Is that right?
X minus.
Minus 1. And we've got the interval from, what's our interval, 2 to 3? And then they tell us n equals 4. Okay. We want the right sum of 4. We don't have to calculate it, just write it out as a sigma. So that's summation k equals 1 to 4 of f of x sub k times delta x. Okay, that's the basic format of a right sum. It's a Riemann sum that I'm using as my special x is the right end of the interval. Now I can use the thinking we did over here to convert it to just a function of k's. So this would be summation k equals 1 to 4. F of starting point is 2 plus k times delta x. And I need to plug in what delta x is, so let me go ahead and just change that. So delta x. Delta x is 1/4, so for 1/4. Okay, and now I'm almost there. All I have to do is plug this x value into my function, and I should be there. So that should be the sum k equals 1/4 of the square root of 2 plus 1/4 k minus 1 times 1/4. I guess I could simplify that a little bit if I wanted. X minus 1 is 1, so I guess I can 1 minus 1/4 k. That's what I would get. Did that answer your question, Josh?
Yeah, I think so.
I'm not sure what the book has, but to me that's a function, using sigma notation, a function only of k. And now if I literally let k equal 1, 2, 3, and 4, I would get my approximation of the area under this function. You all understand? Why don't I have an n in this function? A moment ago, right here, I had n's in my function. What's different over here? I did a right sum and I got an n in it. Why can't I put an n here?
Because n is 4.
That's right. You actually had a 4 instead of an n, first of all. But why else? Because the format is not a polynomial of degree 3 or less where I can use these special summation formulas to substitute in. In other words, here I was able to put 100 in, even though that's a fixed value. I was able to put 100 in rather than just an in. But I can't convert this one because I don't have a polynomial degree 3 or less. There. So on this one, at this stage of the game, all we can do is approximate with a small number of ends.
Okay, so a polynomial is required to find an exact area?
For now. Again,
Are you saying
the
it can't
reason
be done, like, can it not be done with like a linear function?
linear is polynomial of degree 1.
Alright. I was thinking quadratic.
Now, what we were given in this book were 4 special summation formulas. They were for a degree 0, which is summation of the number 1, a degree 1, which is summation of k, so that's linear, a degree 2, which is summation of k squared, that's quadratic, and then a degree 3, which is cubic, summation of k cubed. Those are the only ones we know in the book. Others are even more complicated than the last 2 of that one, far more complicated. So using only those 4, the best we can do is a degree 3 polynomial to get an exact answer like this right here.
So we can't do it because it's a square root function. Is that what you're saying?
Cannot get an exact value at this stage because it's square root. It is not polynomial degree 3.
Okay.
Although curiously, we'll learn in Calc 2, we're foreshadowing, how all of your transcendental functions, or almost all of them, including square root, which is considered transcendental, including trigonometric, which are considered transcendental, they're called transcendental functions because they transcend the normal. Normal being what you think of as polynomial. But we can, in Calc 2, learn how to write them as an infinite polynomial. Sin of x can be written as a polynomial with infinite terms added together rather than finite terms. So the difference being that a finite polynomial versus an infinite polynomial are will be transcend. Anyways, that's foreshadowing. So test tomorrow. We can have extra time again. I'll start 15 early. Or start on time up there.
Oh yeah, do you guys have the same days off for Thanksgiving break?
We have Wednesday through Friday off here.
Okay.
Is it cold there as well?
Yeah.
Cold here. All right, see y'all tomorrow.
Think so. They are. Are they?
Grand Mountain towards the mountains, close.
For extra credit for the fact that he ditched us at the competition because of our dishwasher.
Well, I don't know. I sort of hate curves. We got curves.
You just got dumb, dude.
Hey, Rayo.
Yes?
We should have asked him for extra credit because he ditched us at the competition.
Oh, you could have done that. Or you could have called upon Dale Boger to help us out.
Oh my goodness, no. That was so awkward. I was really kind of creeped out when he said we needed to talk later. I was like,
Yeah, I bet so,
about
dude.
what? Our family history?
Yes, your family history is the Bogers. Is Boger English or is it like French or something?
It's German.
German. Boger.
So when I went to church yesterday, this guy got up in church talking about the blood drive, and his name was Sam Boger, and I was like, so interesting.
Sam, but your last name's popular.
Here's the thing, okay, so we rarely meet someone named Sally, and 'cause that's my sister's name. And we went to this conference with our youth group, and there was a Sally Boger at the conference, and we were just like, oh my goodness. And it was so funny because they have so much in common, and they write the same. I was like, that is you in the future, Sally. There's no other explanation for this.